at the equation, can you see that you have a non-permissible value of x equals 2? A good idea would be to factor this equation out first to see if that non-permissible value cancels out. It doesn't in this situation, so then we know it's going to be a vertical asymptote. Second, can you see that this is group 2? That we have the same degree, a line on the top, as on the bottom. We have a line over a line. That 3x over the x tells us that there's going to be a horizontal asymptote at y equals 3. There we go. I just wanted to highlight that 3x and that x. And then we know, if we just look at those coefficients, as x gets really, really big, subtracting 12 and subtracting 2 won't really matter. We will get really close to 3x divided by x. Right? One person has 3 times x minus $12. The other person has x minus $2. If x is a billion, we would basically say the one person has $3 billion. The other person has $1 billion. And 3 billion divided by 1 billion, that's 3 times as much. So we get that horizontal asymptote at 3. Now, you can see the x-intercept and y-intercept from the graph, but you're going to be given the equation and asked to draw the graph, so these will be important points to find. The easier one is the y-intercept. You can find a y-intercept by plugging in 0 for x. If I plug in 0 for x, I would get y equals negative 12 divided by negative 2, which is 6. And sure enough, our y-intercept is at 0, 6. An x-intercept, you plug in 0 for y. And if I do that, I get the following. Whether I use, maybe I'll take the factored form. And if your function is factored, which it is in this case, right? And if it's a rational function, basically you can just ignore the bottom, because you could multiply both sides by x minus 2. That would get rid of the bottom on the right, and the other side would stay 0. So you're really looking, where is the top equal to 0? What would make that 0? And since it's factored, it's easy to see that x would have to be 4. In fact, for any fraction equal to 0, the only way a fraction is equal to 0 is if your numerator is 0. Like 0 over anything is 0. So we're really only concerned about our numerator. What would make our numerator 0? It would be 4, and that's how we have 4, 0 as our x-intercept. When writing domain and range, the domain is everything except x can't equal 2. On the exam, if you just wrote x can't equal 2, they would assume everything else is there. You can add this, just x can't equal 2, just a reminder, I include everything else. That's what this x equals. Same thing with the range on this one. The range is everything but y can't equal 3. Y is everything else. So on the next page, we have the official rational function definition. A rational function has the form f of x over g of x, where both f of x and g of x are polynomials. Polynomials are anything with variables, with exponents that are whole numbers, no exponents that are fractions, no exponents that are x's, no square roots. So as long as you just have, and most of ours are going to be like this, just with x's, x squareds, x cubes. And we're going to look at characteristic number 1, non-permissible values. And sometimes our non-permissible values are going to be asymptotes, and sometimes our non-permissible values are going to be holes. And I'm going to just write this down, just so you've seen it. Most of the time, if you're going to be writing about it, you'll probably like to write the word hole, because it's a lot less than writing out a point of discontinuity. Okay? But it has happened on the exam, where they say the following graph has a point of discontinuity at, and then about like, what does that mean? Okay, that just means a hole. When we talk about a graph being continuous, it means you can draw it without lifting your pencil. If there's a hole in your graph, you have to like, ooh, I have to jump over that hole and start drawing on the other side. So that's why it's called a point of discontinuity. It's either going to be that or a vertical asymptote. So how do we know? Well, we know when something cancels out. So this first example, the x minus 3 and the x plus 1, once it's factored, neither of those factors are identical with the x plus 3 on the top. So nothing can simplify, nothing can cancel, and those both become vertical asymptotes. But when you have the identical factor, like in this situation, these x minus 3's are identical, so you can simplify that, and then your new equation becomes just x plus 1, but you still have to state that x can't equal 3, because in the original equation, 3 was a non-permissible value. When we graph this, we get a hole. And to find that hole, maybe you want to make a note. You find the hole by taking that non-permissible value that just canceled out and plugging it into your new simplified equation, right? Where's our simplified equation? It was this one right here. Once you cancel out those x minus 3's, your new equation is just y equals x plus 1. That's a straight line. That's easy to graph. You graph your straight line like normal. Y-intercept of 1, slope of 1. Except you have to add the hole where that non-permissible value was. So I know my non-permissible value is 3. I can find the y-coordinate of my hole by just plugging that into my new equation. So when a non-permissible value gets canceled out, we're going to get a hole on our graph. When a non-permissible value stays, we're going to get a vertical asymptote. All right, we're going to go to example 1, but I've got some steps for you, and you have some room on page 106. So I'm going to give you some time just to write this out, because this is the idea that we do every single time for every graph, even though every graph is going to look different. So you have space on page 106. And I'll give you some time to write this out. So the way the textbook has set it up is they kind of want to ease you into it slowly, but we're not going to ease into it slowly. We're going to actually, with each of these equations as they come up, not only, oops, this is question 2. There we go. Here's question, oh, there's question 1. Not only are we going to predict whether it has vertical asymptotes or holes, we are actually going to graph them completely using the steps. So I'm going to take the steps here. There we go. I just want to make them smaller. Put them off to the side. Slide them up. There we go. Part A. Step one with graphing a rational function, you always have to factor completely. So in this equation, the top is a difference of squares, x plus 5, x minus 5, over x plus 5. List my non-permissible value. My non-permissible value, in this case, x cannot equal negative 5. Now the question is it a whole or is it going to be a vertical asymptote? Can this cancel out? Yes. It's an identical factor on the top and bottom. So we know that we are going to have a whole at negative 5 comma something. And we made the note earlier that we find the something by plugging in the non-permissible value into the simplified equation. I'm going to write the simplified equation now in green because that's our green step. If there's a hole, the green step says, if there's a hole, you graph the simplified equation and add the hole. Okay? There's my simplified equation. I can find the y-coordinate of my hole by plugging in negative 5 into that simplified equation. So I get negative 5, negative 10. And as a result, I can now graph, well, I need to graph this line, x minus 5. What do I know about this line? I know this line has a y-intercept at 0, negative 5. It has an x-intercept at 5, comma 0. And I know that it has a hole at negative 5. And my arrowhead's on the end. Draw my straight line. Add the hole to the straight line. And this graph, we did not need to do steps 3, 4, and 5 because the green graph was no longer a rational function. The green graph was a straight line. So that's where this green note comes in. If there's a hole, you graph the simplified equation. Sometimes your simplified equation is still a rational function. And you're still going to have to go through steps 3, 4, and 5. But this is the easiest one. The easiest one is when you have a hole and you end up with a line. You do a little happy dance. You're like, yay, this is an easy 3 marks. I know how to graph lines. Part B. I'll just rewrite the equation, 4x plus 2. Start by factoring, so you can factor out a 2 on the top, gives me 2x plus 1, and on the bottom, I have x minus 2. I factor it because I want to see if there's a factor that's an identity. List your non-permissible value. X can't equal 2. And now we have to determine if this non-permissible value is going to be a whole or a vertical asymptote. And in this case, there's no x minus 2 identical on the top. It doesn't simplify. Are you okay with the abbreviation VA for vertical asymptote? Vertical asymptote at x equals 2. Little details to notice. When we write a non-permissible value, we put a line through the equal sign to say x can't equal 2. When we write the equation of a vertical asymptote, it's an equation of the asymptote. It has an equal sign. You cannot put a line through there because you are actually, you know what, I sometimes even put it on my graph right away. I know, with my red pen, that I'm going to have a vertical asymptote at x equals 2. Now, Since we didn't get a line, we still have a rational function. We are going to have to go through steps 3, 4, and 5. Step 3 is now determining if there's going to be horizontal asymptotes or oblique asymptotes. So what does it say? Which group is this? Is this group 1, group 2, or group 3? Look at the degrees. Is the degree bigger on the top? Are they the same? Or is the degree bigger on the bottom? In this case, it's a line over line. The degrees are the same. When the degrees are the same, you will always have a horizontal asymptote, and we have a horizontal asymptote because that's what happens when x gets big. When x gets big, you just have a 4x over x. You will have a horizontal asymptote. Are you okay with HA for horizontal asymptote? At y equals 4. 1, 2, 3, 4. We can draw that in. That's step 3. Yeah. So you get the 4 from, if you have group 2 where you have the same degree on the top and the bottom, you just have to look at the coefficients of that highest degree, which is 4x over 1x, and see what fraction that simplifies to. 4 over 1 just becomes 4. So that's how we get our horizontal asymptote. Next, step 4. Label your intercepts and your nice points. You will always find finding your y-intercept the easiest because you plug in 0 for x. I often like to go back to my original equation for this. Both those yellow highlighted parts would go away if x was 0, right? So we just get plus 2 over minus 2, which is negative 1. Draw that dot in, 0, negative 1. Next, your x-intercept. When you plug in 0 for y, you would have 2 times 2x plus 1, I'm going to write the factored form, over x minus 2. And again, the only time a fraction is equal to 0 is when your numerator is equal to 0. Technically, if you wanted to, you could multiply both sides by x minus 2 to get rid of your denominator on your right, but your left side would stay 0. So I don't mind if you just look at what's circled in green and right away say, what would make this 0? Well, I only have the one factor, 2x plus 1. Can you see that if x is negative a half, that would equal 0? Same as you've always factored and solved equations before. So again, on my graph, I label negative 1/2, 0. Now in part 4, it says label y-intercepts, x-intercepts, and nice points, 1 per section. So we're going to talk about how this graph, we technically have 2 sections split up by a vertical asymptote. We have section 1 on this side, and we have section 2 on this side. Right now, my intercepts give me points in section 1. You actually have enough information to finish drawing section 1. Your graph in this section is going to go through these points. It's going to go towards that asymptote and towards that asymptote. That's what that section is going to look like. You can never cross the x-intercept again because you found all the x-intercepts. So we find our x-intercepts to make sure we never cross that x-axis again. But we have no points in section 2. So we need to find a point in section 2, and we do that just with a table of values. Like, if this asymptote is x equals 2, I could find any point in this section by either plugging in 3, 4, 5, 6. I could plug in any of those numbers. Usually people just plug the one closest to the asymptote. You see that 3 would be the closest number to the asymptote to the right. That's a whole number. If you go to your original equation or to your factored one, doesn't matter. If I plugged in 3, 4 times 3 is 12 plus 2. Do you see I get 14 on the top and 1 on the bottom? So I could go to my graph and say, way up here, I have the point 3 comma 14. And once you have one point in a section, you have enough information to say, well, it's going to have to go towards this asymptote, and I guess I should extend this one up. It's going to have to go through that asymptote. 1 point is enough. And it wouldn't matter if you labeled 3 comma 14, or some people would label 4. What would happen if I plugged in 4? I would get 18 divided by 2, I would get 9. Somebody like, ooh, I like that point better, because it's not so high up. It really doesn't matter. Okay? You're like, ooh, maybe I'll try 5. It won't be, no, 5 might be a fraction. So you're like, but it doesn't matter. You can label your fraction either. Once you have 1 point in a section, your graph in all rational functions will go towards your asymptotes. And there are a few things, sort of as checkpoints to make sure you didn't screw up. If you add another x-intercept that you didn't find, you've screwed up. There's no other x-intercepts other than the one that we found. So if you all of a sudden made a mental math error and your extra point came here, and then you drew this section, you would add another x-intercept and be like, oh, wait a minute. I probably did some mental math wrong. So this is the idea of all 5 steps. What we do is we start off with our non-permissible values. Our non-permissible values tell us vertical asymptotes or holes. If we need to keep going, we have to see which group it is. If the degree is the same, you have a horizontal asymptote at y equals whatever the coefficients are. If the degree is bigger on the bottom, you'll have a horizontal asymptote at y equals 0. If the degree is bigger on the top, we're going to have an oblique asymptote. And we haven't found out how to do that yet, but we will. After you've found your horizontal or oblique asymptotes, find your intercepts. Sometimes your intercepts is all you need to find, and you have 1 point per section. And when I talked about sections, sections are split up by your vertical asymptotes. So if you had 2 vertical asymptotes, you'd have 3 sections to graph. You need 1 point in each section, and then just draw your graph towards the asymptotes. Question you can circle for this one is number